Welcome back to our Scala to Spark class. And we are looking at Spark rollup and continuing today with cube, and also then we will look at joins later on today. So cubing is basically just like rollup. Again, it's just like it's basically group by operation. In fact, if you look at the documentation, it comes by here. The cube is actually here under group by. Here, right? So this is grouping by everything. Basically, you have two. If you group by let's say two columns, date and country, right? You'll be able to aggregate across everything, basically across all dates and countries, right? For each date, for each country, and then also total for each date as well. Across, so it's very similar to rollup basically. So I'll keep this information under rollup. So technically we're on day 30 today, but I will keep it under day 29 since we are so we can continue on the same code. I don't want to reinvent the wheel. So again, it should be very simple, right? So exactly the same code, except so there will be some difference. So the difference will be, I'll show maybe, again, show not everything, but okay, I'll show maybe, I don't know, 40, okay. And so we're showing date, country, some quantity, right? And we'll see, so aggregation is quantity. We could of course do aggregation of something else as well, of course, some maybe total or something else, right? So let's take a look, right? So we can do also some other. Let's see, maybe some total, for example, as well, right? But let's run it first. So this is basically a shortcut. You could do everything. I mean, if you didn't know that such a cube exists or such a rollup also exists, you could do everything by group by and do individual aggregations for all of these combinations, right? You can say, okay, get me a sum of all, just everything, basically, right? Get me a sum of all dates, right? Group by date, group by country, and then group by date and country. So let's take a look. They do ordering or order by date. I ordered by date. Yeah, I ordered by date. Okay, good. Okay, so let's take a look. Or top 40 rows. Okay, so we have null. Right, so this is everything, right? Again, very similar how here, right? Right, yeah, we got the same one, of course, right? What else? So null country, but difference should be, yeah, we don't have a, you see, that's the difference here, right? You had a date here, you have also no date, and you have country, just country, basically, right? We did not have this here, right? We had the just date, but we have dates and also we have so also Norway here as well, right? So we could also do so there will be, maybe I should show 50. You will see that there's also on a date there will be also a null version here as well, and of course I can add some other things like such as sum total, for example. That might be interesting, right? Right? I'll call it, I'll just say sum total, right? I'll add it here. Aggregation, I can do more aggregations. 1, 2, 2 here, comma. Yep, and I can do more, I can add more columns, of course. So again, so very similar in concept to rollup, except the difference being we also get the first, we get the version when null is, when there's nothing found for the date. That's when we have the actual second basically count. We have these operations over just the second column, the country column, basically, right? So again, it's a way of quickly generating everything, basically stats for everything involving these two columns, basically, right? We can do some other aggregations. Let's see, it's still working. Did I didn't select, oh sorry, I didn't select it. Okay, yeah, I should select that too. And I have to type sum total, right? Let's see if I get it right. Yeah, I should probably have renamed this, right? Because, okay, that's the name of it, right? Sum total, sum quantity, sum total. Okay, let's run it one more time, and then we should be done. Oh, okay, we have top 50 rows. Yes, we do. Indeed, we do. Do we have null? Right, so France, yeah. So, notice, right? So, null, right? Which is just like in a roll. So, we do have this also. So, we have everything for December 1st, right? All the countries. And then we have everything for that date, of course. And of course, since this is you generate, this is a date frame, we can afterwards, we can do filtering like we did with, we can just do regular filtering. We can save the results of this cube, right? And we can, query those results afterwards, basically. So, again, so it's basically basically 4 operations in one, basically. I mean, four different groupings in one, right? So date, country, date and country, and everything, of course, everything being here, right? Null, where's my null? My null is this one here, right? Where's my null? I saw it here. Yeah, that's everything here, right? Okay. So I should have done round, right? And so on. Okay. Yes, it's to maybe it makes things slightly more complex. There is a concept of grouping, right? So when you do cubes or rollups, right, you might want to do a query for the aggregation levels, right? So there is a grouping ID which tells you the level aggregations that we are using in our result set. So this is right. So for example, since if you're doing cubing, right, so 0, I'll start with some 0. So the 0 will be individual columns, basically, what we're doing is individual columns, right? So level 1 will be well, per customer, because we started the first column, right? Second will be for stock code, right? And this will be the highest level, basically, right? So, oh no, okay, actually I'm wrong. I'm reversing this. This will be, like I said, this is the highest level. So this means this is everything, right? This is null, basically, right? And this is individual, actually. So this would be level 3 would apply to null, right? However, this would be the total quantity. Let's see, can we add this? Let's see. Yeah, we can do add grouping ID. So let's add it, basically, cube, right? And we should add this here, and we should see it, basically, right? So it's basically it's a metadata for grouping, so you can filter it slightly more, right? Stock code. Well, let's see, what do we have here? And do we have yeah. So again, no. So this will be 3. Yeah, like I was right. Okay, I was right. Okay. So grouping ID. Okay, let's try this version, but this same thing, basically, right? So we'll see here. It's not that. So I need to import it. Yeah, of course. So yeah, it's basically tells you what kind of data you're dealing with here, right? How the grouping was done, in case you forgot, basically, right? So it's a quicker way of doing filtering instead of checking for nulls, basically. So this should be level 3, and again, so this would be, I guess, level 2, and the other one would be, and this would be level 0, right? So this is everything. Each country and each date, separate aggregation for these. Of course, the question is now, what happens if you do 3 columns, right? I imagine then it would explode. Those levels would explode, right? And you would have 8 different levels, right? That is because 2 cubed is 8, right? I guess so. When you cube the combinations, basically. But let's see. Okay, so we have 2 columns, right? And what else? Let's see. So let's see the result, right? And again, I should be able to add, say, sum total maybe also should work, just in case, so you can see. And interesting. You're not selecting anything else. Okay, let's take a look what's happening here. Okay, right, so of course starts is level 3, right? Then this is level 2. I will then want to get level 1. Why not? Again, so it works, of course, right? Custom ready stock code, right? So let's do it. I'll add grouping ID to our let's add it to our previous one here as well. There's nothing, right? Why not, right? And I will add it here, right? Column, so grouping ID. I'll just call it here. I think it's like this, yeah, I think so. Okay, let's take a look, right? Yeah, okay. Of course, I could rename. Of course, you could do as, alias, or as, right? Should be. You could also rename it. Of course, let's see. And hopefully by now you should have a good idea how these grouping operations perform. Okay, no errors. Okay, that's good. Yeah, so maybe here we'll see. Yeah, we see 0, 1, and 2, and 3. Okay, we see everything. Okay, great. So it's 2, right? Because it well basically refers to the not because it's the second column, but basically, yeah, which is 2 and which is 1. I guess 1 is the referring to the first column, and second does not exist. Second is for the second column, right? However, so 3 is when you everything, right? So everything versus everything, this is 3. So that only in a cube operation you'd only have a 1 3 operation, right? So I mean the grouping ID 3 would be the only, there's only one basically, right? Because that's everything, right? That's everything, right? So there's no other possibilities, right? So for the second column you have a grouping ID 2, and so 0 is the ground level. So this is like the full grouping. So this is what basically for the if you do just regular group by country and basically without the cube, right? Just the group by, instead of cube you will use group by, and then you have the regular aggregations. This will be the grouping ID of 1. Okay, so that is pretty much all about grouping. Of course, you should play around and get maybe a better feel for it. We do have one more thing, which is pivot, right? So again, I'll leave it in here, right? So pivot, maybe those who have worked with Excel probably know what pivot is, right? And also this is present in databases, of course, in analysis. So basically, we can pivot a column, I mean a row into a column, basically, right? So so we can group by, let's say, group by date and pivot country sum, for example, right? So let's take a look at this, right? So we group by date, each date, right? We can start doing something on well, let's take a look actually how it works, right? So we should have a column for every combination of country, some numeric variable on the column with the date, right? So let's see how it looks. Should be able to see for each country. We should see the dates basically. And let's see. Yeah, okay. So this is slightly maybe not as maybe I'll show you also how pivots in general. You know, I don't know if SQL has pivot. I don't know if it had. Actually, it does. I know Microsoft Server has it. Of course, I don't think the plain SQL. I don't know if SQLite might not have it. I think, right? So you can check it out, right? It is here basically. It's probably again slightly. So we are transforming columns basically. But I think let's better take a look at this, what's happening underneath, and then we can explain it afterwards. So I think it's better to see that the actual example, right? Right. And if of course we're gonna save it, we're gonna save the results for now, right? So this is gonna be data frame, of course, right? And let's see what we have, right? And so I'll just do pivoted show for now. Pivoted show, maybe 10, I don't know, 20 files, right? Pivoted, right? So again, we have so what do we start with? So of course I'll do this first. What do we start with? Def with date, show 10, maybe show 5 files, right? That's what we start with, right? And we go to this result here. So let's take a look. And so we're grouping by date, and we pivot the country. Okay, yes, all right. So there we go. And basically, so what we can see, our pivot was country. So we created should be, so look at all the columns we created. So because we have how many countries, right? So we had the column country right here, right? Of course, and we could, of course, I should maybe do. I could do, how was it, distinct, right? We could do distinct, select column. I would do is select. I think I can do this. Can we do this here? Let's see how many countries we have. Df is date. Select. I'll do a select expression, right? That's the easiest. Distinct. Distinct country, right? Yeah, that should work, right? Show ordered by. I'll just show all of them, right? Ordered by country, right? And maybe ordered by country. Yeah. Okay. Control Z. Right. So here we go. Order by, what's the problem? Did I not write correctly? Order on. What's going on? Oh, I guess I don't need column. Oh no, here's the problem. Okay, and show I don't know, 20. Right. What's wrong here? Maybe I don't need this, right? I forget now. Yeah. Okay, we're good. Okay. So let's take a look, see if this works, and see if we can do this. How many countries do we have? I think we had more than 30, but then I will see. Right, let's run it. Okay, I guess my country, my distinct didn't work. Ah, really? Distinct. I can't type. Am I really not typing correctly? So Spark SQL. Spark SQL. functions. Which one did I miss it? Built-in functions. Come on, I can't really type. Really, I guess not. I guess I don't have it. I thought I am. I'm just maybe not. Huh. I guess not. But then I have to use regular SQL. Regular SQL has it. Huh. I thought I had Spark. Distinct. Right. Distinct. We could use this one also, right? Yeah, okay, we could do this distinct. Yeah, okay, I guess I'll try using that one. I don't know why it's not working. I'm just maybe something's not. Maybe if this is live class, I could do so select. I'll just do select, and I'll use a function. Okay, why not? Distinct. I think I can do this. Let's see. I need to import, of course. Import. Really? I could do drop duplicates. Distinct. I'm not really sure. This is not really something extra thing I want to do. No? I guess it's not here. Ah. It's not in the functions. I thought it would be available. Huh, interesting. I guess, okay. I guess, yeah. Ah, it's in here. It's a method. Okay. So I got, okay, it's a method. Okay. Haha. So, it's a method. 1 second. 1 second here. So we are dealing with distinct. Actually, yeah, it's a separate. It turns out it's a separate method actually. So we can call it at any point when in a data frame, as long as we have data frame, it will have distinct number of rows. Of course, if you only have a single row like here, it should pick up the countries. We could do, of course, order by afterwards as well. Okay, so let's see how this works now. It shouldn't be no error. I'm still puzzled why it's not picking up on select expression, because distinct is, of course, the regular SQL command and function, so it should be available. It should probably works in Spark SQL, of course, it should be available. But okay, but that's of course besides the not the theme here. We are trying to see how pivot works actually, right? So I just want to show you how many countries we have, right? So we'll have a huge data frame of every country, right? And we have sums for every numerical column. So it's quite powerful, but of course it will generate very sparse sets. Why? Well, of course, because not every day Austria buys items from this shop, right? So Australia bought quantity, sum, also total. You can see how many, so it's very powerful, right? It's like unrolling. You could say, I don't say unroll, but basically, yeah. So pivot, actually, that's the correct name, right? So by each, we did a group by date, right? So for each date, Scala, this Scala Spark engine, it will go through all the countries available. Let's see how many we have. Yeah, actually not that many. Well, actually, I guess more than I thought. And also, I should have ordered afterwards, I guess. They're not ordered here. I guess I should do it order here, right? Maybe I'll add it, right? Right? It's still country, right? Yeah. And you could of course do a count. So of course, only showing top 30 rows, right? So this looks like there's more than that actually. So what this means, of course, this pivot is going to be huge, right? Look at this. Oh my God, right? So that's probably United Kingdom, probably, right? United States. Do we have United States? Yeah, we do have unspecified sum. That's very interesting. This is probably, I guess, I don't know what this is. Everything else, United Kingdom, right? Do we have United States? No, we don't have United States actually. So I guess. Oh no, the USA is covered also. So you can see immediately, of course, in this really. Of course, I only show 25 rows, right? Right. So you can see immediately day by day breakdowns. Very powerful technique. Right, if you do need to do some analysis for, again, it generates very sparse data, of course, right? Will generate sparse data, right? So notice a huge, very long, many columns, right? Many columns equal to distinct country count times numeric columns in original def with date, right? Numeric columns, right? So because for which each we applied some function. Of course you could still do some other function too, but some would be right on each got a some function. Okay, of course you could save this again to a file, right, for analysis if you want. Okay, so that concludes our grouping operations, aggregations, right? Again, probably the most, like, say, powerful techniques for general analysis, but there's also mention, if you are want to dig deeper, it's possible to make your own aggregation functions, right? But it's quite a bit of extra boilerplate, right? You have to define a schema, a buffer schema, right? It's again not very often you will need this, but again it is possible, right? So if you need to, you'll be able to just look up. I'm sure by then, if you get that far, right, you'll be able to find your own function, right? So quite nice actually. You just register. It's very similar how we made the UDF functions, right? In the process, right? It's just the syntax is different. But I won't basically insist on it, right? So yeah, so in Scala. Okay, so I think it's time we close this. I close this part of on aggregations, and we move on to joins. Okay, so I'll save this here. Commit. Pivot, so cube and pivot, date 30, oops, here I can't type, date 30, cube and pivot, right? I think pivot's pretty cool, right? So commit and push. Oops, I don't want to commit everything. These are all junk. Sorry. Whew. Like good thing this is multi. I don't want these. Well, actually, there's nothing really bad here. These are just CSV files, but still, I only want to do one. Let's see to check. Okay, now just one. No, sorry. Yeah. Okay, one. One single file. Okay, full. So this is again. That's why if you have a fat finger syndrome, right, pushed one commit. Okay, great. All right, so let's move on to our actual date 30, right? New Scala class, object date 30 joins, right? And of course, the good news is, of course, this is nothing completely new, something we already covered in or regular SQL, right? The principles will be the same. It will be just a question of syntax of how we do it, basically how we do it technically, right? So again, this book assumes you don't know about this, but we know about it, right? So we join two sets of data, right? So this will be our print line, right? Chapter 8 joins, right? And of course we can do it now. I'll get, of course, Spark. Gets done. Right, and we'll see. We'll need to generate some data. So, and of course, the question will be what kind of joins we do, right? What kind of joins are supported by Spark? And we remember when SQLite originally did not support all types of joins. Lately, they actually, as we were doing this class, they added more extra joins actually. Right, you had to do some extra work here. So basically, the type, right, the join types, right. If you do this here, the types of SQL join, right, and we have now some images, right. You can look at here, right. So inner join, right join, left join, full join, right. So basically, we want to have, when we join on some column, basically we're joining two tables together, right. So inner joins, right? So when we do inner join, which is most typical, this is the most typical. The basic inner join is you need the keys, right? The match should be on both sides, right? You have two data sets, right, left, right side, right? and you have some, let's say you're joining by some ID, maybe somebody has a primary key, somebody has a secondary key, doesn't matter. You're doing a join. So if they both exist, this row is going to be kept, right? Okay. Then there's left outer join, right outer join, right? So there's some other variations actually, right? But outer join is when you don't care, you need a key in at least one side, right? Other side might be missing this join. So by definition, inner joins will be the most specific ones, right? So left join, left outer join is basically you keep the keys in the left data set, maybe right set might not have it, right? So again, you check the keys, right? So it keeps the row, right? And if there's no match, right, then you discard it, right? Right. So we'll start with inner join. I hope we start. There's some cross joins, of course, with everything, right? So again, very similar to what we have here, and yeah, we'll use a very basic data set, right? So again, I can write this here. I can give everything here, I guess. Join types, right? Again, lots of extra help for you, so you don't have to buy the book. But right, so and we'll have three data frames: person, graduate, program, and Spark status, right? And I'll probably add myself here somewhere as well, right? So I'll add myself, and of course, question might be. What in the world is this? Spark status. Interestingly, some sequence, some extra program, basically some extra thing, right? There's some programs, right? And so this will probably be a foreign key. Yeah, graduate program, right? Yes, and Spark status, of course, is a sequence of ID. So some data here. I don't know what the heck that is, but okay, it's just I think it's just made up. It just made up some information. Okay, so I will do this, right? So very simple database, right? Of course, I'll add myself. You're free to add yourself. Why isn't this not pick? Of course. Why didn't it work? To df. Yeah, we need to do this here. It's not mentioned here. In order to do this, we need to import. To go to 2df, we will need to actually go. There's an extra thing you have to do. So let me show you. Let me go to my previous project in Scala Spring, new window. There was another thing you have to do. No, that's not it. No, it's not. It's the wrong project. Sorry. Open recent. It's called Spark. Okay, yeah. And we have our joins. Okay, so I'll do. Yeah. Why doesn't it pick up actually? Okay, well, let's say. Oh, wait, we have Spark. No. Why doesn't it pick up SQS? Let's say to df. No, it's not picking up here. Huh. Build chambers. Let's do build. No. Oh, there we go. Okay. There should have been a. No. Okay, Spark is fine. Yeah, this is it. Okay, this is the problem. Yeah. So yeah. So this is one of those things actually, which is a little bit like black magic basically, but implicit, right? Which is kind of cool in Scala, but also makes for some headaches, right? You had to import. I'll import them here, right? Basically, you had to. I think you had to import them here. Cancel. Yeah. It actually says so. Oh no, not like this. Oh, sorry. Here, yeah, we have Spark, right? So yeah, we have to do it here actually, right? So this is a bit tricky, right? Yes. Okay. So basically, so we have to do these implicits, right? Implicits will let us use 2df on simple sequences, right? Basically it will be otherwise, because of course, so it's kind of like magic. So otherwise, of course, because otherwise a regular sequence does not have 2df method, right? That's why we had to use implicits from Spark. It's kind of cool how it works, but it's again, it's a otherwise, of course, you know, sequence, there's no, and if you look at documentation of sequence, there's no such thing as 2df, right? I mean, it's not meant, it has nothing to do with Spark by itself, but using these Spark implicits, we can actually use this we can have new extra, we can add extra methods, basically, right? So to say, basically. But it's slightly more complex than that. Actually, there's the types you have to define. You could do your own magic like this. But it's the good news for you is that Scala is moving away from these implicits, maybe a little bit more, right? So basically, Scala's implicit methods are available in Scala for converting common Scala objects into data frames, basically, right? So, all right, so very kind of cool, right? Cool idea, right? It's just that what I don't like about it, but what's a critique of this is, of course, that it's impossible to say. If you see something like this, you can't tell immediately where it came from, right? It comes from here. No, it doesn't come from the sequence, right? So that's the critique. Okay, of course we could have just regular, use regular other data frame creation, right? Okay, so now that it's working, it should work, right? We have two new data frames. I'll show myself. I'll add myself, right? Of course, right? I'll add here. So I have my primary key, right? Okay, here we go. 3 multi-source, right? On, I don't know what school I'm going to, right? I'll go maybe 3, right? I don't have it. Sequence. I don't know what the sequence is. I don't know what that is really, but something like that. I don't know, some extra data. I'll try to keep it myself. So 3 and 3 here. Well, okay. I'll go to Berkeley. Okay, I'll go to Berkeley Masters. Okay, why not? Right? Okay. Right, I'll go to, okay, why not? Right, I don't have PhD, but so masters, okay, right. So, and of course, I will show myself here as a person. So, person show, right? Yeah, okay. We can of course do also graduate program show, and of course we can do Spark status show, right? We could also do print schema, of course, as well. Let's see this method. And I want to run it again, not day 29, but day 30. Let's do this. Okay. Looks okay. Yeah, looks we have 3 new show. Okay. Okay. Okay, I remember what this Spark status basically. Okay, it was basically an ID for what's your. So you could be basically, the idea is that this represents Spark. You can be doing multiple things. So apparently I am a contributor and I am PMC member of this committee, maybe of Spark. Right. Okay. Which is not true in this case, but okay, right? So it's, of course, this is a compound data type, right? It represents multiple because, of course, just to make our life maybe slightly more complex. Of course, not every it's not required. You have this column, this type of column, of course, right? But we have so we have the basic idea of ID for the some sort of ID, primary ID for each data frame, right? And we also have some references to other tables, of course. These are not strictly enforced at this moment, right? It's just that we decide to, let's say, graduate program, right? And and of course this is, so it matches these, right? So basically I'm going to number 2. I had masters in electrical engineering from UC Berkeley, according to this data frame. Okay, so and also, like I said, I'm a PMC member and contributor. Okay, maybe I'm a contributor, but not a member of this committee. Okay, so that's the case. Now. I'll close this one. I don't need this anymore. And now we can actually do some joins. Right. Of course, yeah. Well, first we'll do in this chapter. We'll use them for we'll do some registration. Of course, I don't think you need to. You know what that does, right? right? Create some for queries, right? So person graduate program Spark status, okay? And now, right, we'll do start with our friend, right? We'll start with our friend inner join, right? So we are going to join the graduate program data frame with the person data frame to create a new data frame. So we will use it. We'll need to create a join expression. Again, of course, as you can imagine, you will be able to do the same thing with regular SQL, of course, right? So if it does not exist, right? So right, name, school, of course, wrong expression, right? It won't even come up. So let's look at this. What is this here? So join expression, it's a column, right? Yeah, it's actually a column, right? That's kind of cool, right? So it's just a regular column, right? We say person call graduate program equals triple equality. That's the only thing you mentioned. So notice the triple equality. Notice the triple, right? Right. So we match a person column, right, with this. So that's our join condition, or you could say expression, right? Oh, now of course we can apply it, right? We can apply it, right? So that's default. So basically just do join, and it's very simple, right? So of course, as you can see here, you can do the same thing in Spark SQL, of course, right? But we'll do this first. So join, right, and show, right, and it should show everything here. So right, so we just need to do the default join, right? Okay, we got it. So yes, so we joined all, of course, by doing this, right? There's one unfortunate side effect, of course, is the column names are exactly the same, right? So we join the join is correct, of course, right? But of course the ID now we'll have to go by column number, index, because 0, 1, 2, 3, 4, 5, 6, 7, right? Because of these names, there's some ID and ID, right? So that's kind of not cool, right? So that's a problem, of course, right? So we'll have to select some specific columns. It will be slightly hard to select the columns. But yeah, so the join worked. Okay, and of course we could do this select all. So you could do this person, right, from person on the graduate program. So we here with SQL it would be of course easier to select the name because you can use regular SQL syntax, person.id, right? Or graduate program ID, right? So you can select the columns here instead of star. But let's try it. It should be exactly the same result. Spark SQL, right? Okay. And we should see nicely show. Okay, and you can see in fact they are same, right? So same, exactly same result. Same Spark SQL. Okay. All right. So that's the JSON joins. We'll in our Saturday session we will look at the other joins. Now the question is, what kind of exercise you want to do? Right? We've been working for a while. Do we have any data sets we could use here? Let me see. Maybe let's see what I did before. We could do so. Maybe let's add some. Let's look at our CSV file. Is there anything we could do with our by day files? Well, we could do a join here by the invoice. Well, invoice number right? You could do joins on those, but this is actually it's the same thing, right? It's the same data, so there's not much point of joining these tables, right? Because they are, you don't want to join them side by side, because right, that's not kind of pointless, right? Maybe customer CV, right? That might be interesting. Is there a customer CSV? Oh yes, so we have some customer IDs. Okay, that actually would work, right? All right, we have Singer, James Bond, and Harry Potter Wizard. That's great. Okay, and the question is now, yeah. So that actually might be fine. Yes. Okay. So I'm not sure if it exists, but let me try. Let me check if Victoria Beckham has bought anything from us, right? From our store on this everything, right? We can do online. I'll do everything here. Okay, 1678. I think she bought something. Yeah, looks like she's been buying stuff. Okay, is that? Let's check if the column is here. Yeah, custom. Okay, great. Okay, we got our exercise. All right. So very simple exercise. So yes, so online retail data set, right? Open up. Let's get this. So this will be your exercise. So open up, and hopefully you can do this, right? Yeah, should be pretty easy, right? We need, of course, copy past reference. So open right here, right? Yeah. So open up, right? Online retail data set, right? So copy. So that will be our to do. And join. Inner join with custom data. But retail data, customers CSV, right? Only customer ID matching inner join, matching ID matching first matching ID in second, right? Okay, I think you got the idea, right? So I want to see basically in other words, I want to see the purchases on full, yeah, of these customers, right? With their full names, right? So basically, yeah. So that's your task. I'm sure you'll be able to do this. Not too hard, right? Pretty easy, right? And so try to show it in both Spark, right? On Spark SQL, Spark SQL, right? Spark API functions, right? Like this, right? On Spark, yeah. Okay, well, that's it. So I'll see you on Saturday at 10 o'clock, and let's have some fun.